Okay, think about all the smart stuff in your life. Your watch, maybe your car, your home, everything's getting smarter. But here's the catch. When billions of these devices are all trying to talk and think at once, it's like we're creating this massive, invisible traffic jam, a digital one. So how on earth do we clear the road? And that's really the big question, isn't it? We've got all this amazing tech, but making it all cooperate efficiently, well, that's a whole other story. I mean, if every single device has to send its data all the way to some far-off cloud server, everything just grinds to a halt. It slows to a crawl. There's got to be a better way to do this.
Well, lucky for us, there is. It's called edge computing. And the main idea here is pretty simple, actually. Instead of sending every little piece of data on a long trip to some central brain, you do the thinking right there, on the spot, right on the edge of the network where all the action is happening. It's way faster, way more efficient, but of course it creates a whole new problem of its own.
So here's the new headache. If you don't have a central boss, a manager telling everyone what to do, how do you decide who gets which job? It's a free-for-all. And if you get that system wrong, you've got some computers completely burning out while others are just sitting around doing nothing. That means wasted power, major slowdowns, and worse, some tasks might just get rejected completely.
And this is where things get really, really clever. The solution comes from an idea that's centuries old: economics. What if we just let the computers bid for tasks, just like in an auction? I know, it sounds a little weird, right? We think of computers as just following orders, not haggling in a marketplace. But what if we created a system where they actually compete for the work?
So how does a digital auction actually work? Let's break it down. What you're looking at here is the basic setup. You've got your tasks that need doing and your network of computers. We'll call them nodes. The magic happens in that simple 5-step process that you see. This is how we bring some order to all that chaos. Come on, let's walk through it.
Okay, so first, a new job pops up and it's announced to the whole network. Kind of like an auctioneer shouting, "All right, folks, here's the next item." Then every single computer, every node, does a quick check. Hey, do I have the power and space for this? If the answer is yes, it crunches the numbers and figures out its bid. And then, you guessed it, going once, going twice, sold. The job goes to the highest bidder. That winner then just updates its status to busy. It's simple, it's fast, and best of all, nobody's in charge.
But hang on, what makes a bid a winning one? Is it just whoever's free? No, it's much smarter than that. The bid isn't just a random number. It's a really careful calculation that balances two key things. First, how much free capacity does the computer have? And second, how good is it at this specific type of task? This is so important because it means the job doesn't just go to any free computer, it goes to the absolute best one for the job.
All right, so that's the theory, and it sounds great on paper. But does it actually work in the real world? To find out, researchers staged a showdown. In one corner, we have the old way, a static method where jobs just go to the first computer that says it has enough space. And in the other corner, our new, shiny, auction-based system. Let's see who comes out on top. And right away, you can see a massive difference. Just look, the top chart shows the old static method. See that last task? It's just unallocated. The system couldn't find a place for it. Now, look down at the bottom chart, the auction method. Bam! Every single task got assigned. A perfect score. That's a huge win right out of the gate.
And if you want the final scorecard, here it is. This breaks down the performance across 4 key areas. And honestly, it wasn't even close. The auction method, those green bars, just completely dominates. It's a total knockout.
Okay, let's look at pure efficiency. How much of the network's power is actually being used? The old way clocked in at about 89%. Not terrible, but the auction method, a staggering 98.2%. That's almost no wasted power at all. A huge leap forward. Next up, how many jobs actually got done? We already saw this, but it's worth repeating. The static method dropped the ball on one task, only getting 11 out of 12. The auction method, a perfect 100%. 12 tasks in, 12 tasks out. No job left behind. Now this one's interesting. The fairness index. Basically, it measures how evenly the work is spread out. And for this metric, a lower score is better. The old method scored a 6.4, which means some computers were doing way more work than others. The auction method? It cut that number literally in half, down to 3.2. It's just fairer. And this chart shows you why it's so much more fair. Look at the computers on the right, nodes D and E. With the old method, they're barely doing anything. They're just sitting idle.
But the auction system is smart enough to give them smaller jobs that they can handle. It makes sure every single computer is pulling its weight, no wasted potential.
And the result of all that smart assignment is far, far less waste. Think of it like a game of Tetris. The old method leaves these big, awkward, unusable gaps in the schedule. But the auction method is like a pro player. It fits all the pieces together so tightly, leaving only tiny little fragments of unused time. It's just incredibly efficient.
And maybe the most important part of all, this new method scales beautifully. I mean, look at this graph. As you throw more and more work at the system, the old method just flatlines. It can't handle the pressure. But our auction method, the efficiency just keeps going up. The busier things get, the bigger its advantage becomes. That's what you call a future-proof solution.
Okay, so we've established it's more efficient, it's fairer, and it scales like a dream. But let's be real, why does any of this matter? What does it mean for you and me? Let's bring this out of the lab and into the real world.
Because this isn't just an academic exercise. This is the underlying technology that's going to power our future. We're talking about smart cities that can reroute traffic on the fly or manage the power grid in real time. We're talking about factory floors with thousands of sensors all working together perfectly to build things faster and better. And imagine getting instant answers from massive amounts of data with zero lag. That's what this makes possible.
So that really brings us to the big takeaway here. We took a simple, elegant idea from the world of economics, an auction, and used it to solve a super complex, modern computing problem. It just makes you wonder, right? What other big, messy problems in our world could be made smarter, faster, and a whole lot fairer just by holding a simple auction?